Hello CSCI-150 students. This is another recording for Python. And in this recording, we're going to be showing an example of decisions or if statements to solve a particular problem. We've seen this or something similar to this problem before. If you look at the very top, what we're doing here is we're entering two integer grades and then doing a computation here to compute the average of the two grades. And then finally, I'm displaying the average of the two scores. So I say the average of exam 1, exam 2 is the average over here, which displayed with two decimal places. The first problem here asks me to, based on the value of the computed average, if the average is 90 or above, display the message excellent. Otherwise, basically don't do anything. So right now, if I were to run the program, and let's say I don't know, I entered 90 and 95, my average should be 92.5. You can ignore all the parts for now, but notice that nothing gets displayed, although my average is 92.5. So that's what we're going to be doing in part one. We're going to be using an if statement for that. So I'm going to say if the value of my average is greater than or equal to 90, colon, and notice what happens when I press enter after the colon. Python automatically recognizes that this is a sub-block in my program, and the way Python defines blocks is by using indentation. So indentation is really important in Python. Don't indent manually. For the most part, Python should be able to do that for you properly. In fact, if you were to do something like this, write an if statement and forget to put colon and then hit enter, notice that the cursor goes to the beginning of the line. That's a sign or an indication to you that you did not do everything you need to do to create a proper block. So at the end, I'm going to have my block here, which means now everything that I'm going to write inside that block will only execute if the if statement is correct. Similar to when we had Raptor, and then you had a diamond, which is decision. You go left to right. If you go left, only the statements on the left execute. If you go right, only the statements on the right execute. So in this particular case, I'm going to be printing the value, the string excellent, but only if the average exceeds 90. So we can repeat now 90 and then 92.5, sorry, 95. I get 92.5 and then I get the value excellent. And then I'm going to try it again to make sure that excellent is not displayed if my average doesn't meet the criteria. So if I have 90 and let's say now 89, the average is going to be 89.5, and I'm not going to get the string excellent in here. When you write programs like this, especially with if statements, you really want to make sure you're testing your programs for different values, especially boundary values. In this case, the average being at 90 is a boundary value. So you want to input some cases to test average equal to 90, average slightly greater than 90, and average slightly less than 90. So for less than 90, just like in this example over here, 89.5, it didn't display. For average equal to 90, so I could do 89 and 91. The average is 90, it displays excellent. And we saw above 90 that it does that for us. Anyway, moving on to problem 2. In this one, we need to use two if statements now to display excellent if the average greater than or equal to 90, and then not excellent otherwise. Okay, so I need to do something like this. So notice now when I hit enter after print, it's going to assume I'm still in the same block. If you wanted to go to finish the block, you just press the backspace button on your keyboard, and that'll take you to beginning of the line, meaning that you completed the current block. So I'm going to say if average now, the opposite condition is less than 90, print not excellent. Okay, so now I'm going to repeat the same test as before. I'm going to try at 90, 89, 91, It's going to give me both excellent, excellent, which is what you expect because the average is 90 or above. And if I were to try it again now with 89 and 90, I'm going to get nothing in part 1 and not excellent in part 2. Now, one of the things we learned in Raptor is that every decision, you could actually take 2 different actions on the same decision, if it's true or if it's false. And if you notice here, I am being redundant in the sense that I'm saying, if my condition is true, do this. And then I'm saying, if the condition is not true, do that. So we don't really need to do that. We could just use an if-else statement to achieve the same outcome, since else basically means if for anything else other than average greater than or equal to 90, meaning it's less than 90, display not excellent. Okay? So again, else will create its own block, and this part over here should behave exactly like part 2, but it's much more elegant. So try it again, 89 and 90. In part 3, we should get not excellent. And then 89 and 91, we should get excellent. So it works for it. The last one, the last problem here, this just to give you an example of using nested ifs. We're going to come up with a much more complex example. So I'm going to copy number 2 and put it over here. And now the task is to display 3 different messages. If it's greater than 90, display excellent. If it's between 80 and 90, excluding 90, of course, display good, otherwise display more work needed. So now this is the first one. If it's greater than or equal to 90, display excellent. If now I want in this range, so if it is less than 90 and average is greater than or equal to 80, I want it to display good. Okay. And then finally, if average is less than or equal to 80, I want it to print more work needed. I'm not saying this is the best way to do this. In fact, this is not a very good way. For the similar reason we talked going from part 2 to part 3, but this is a good start. So if it's greater than or equal to 90, print excellent. If it's strictly less than 90, greater than 80, my bad, print good. And if it's less than 80, print more work needed. Notice the use of the and. This allows us now to create what's known as a compound condition in Python. You could use ands and you could use ors. Ands evaluated true if both sides of if both conditions on both sides of the and are true, or evaluated true if either of the condition on either side of the or evaluates to true. So in this case, this condition evaluates to true if average is indeed less than 90, but it still exceeds 80, equal to 80 also. So let's try that now. And now we've got 2 different boundary values to worry about. There's the 80 and then there's the 90 also. So I'm going to try 89 and 90. This should give me, for part 4, should give me good because the average is 89.5. I'm going to try now 90 and 91. This should give me excellent. And then I'm going to try something less than 80. Actually, I do have a problem in my program. We'll figure it out as I try this last case. So let's try 79 and 81. And notice that my program for part 4 displayed 2 messages. You should be able to figure out my mistake. It's because I included equal 80 in both conditions. 80 should be here, but not here. So we need to get rid of that. And that's like a teachable moment now. This is why we really need to thoroughly test our programs before we trust that they are actually doing what we expect them to do. So try again now, 79 and 81. It should give me only good. 79. Oh, I meant to write 79. Okay, so let me try that one more time. 79, and 80, we should get now less than 80. So it should display more work needed. This, as I said, is not the best way to write it because, as we talked about before, if it's greater than 90, then none of the other if statements should really execute. So I could utilize something similar to what I did before. So I could say something like else, and then make everything we've written earlier to be part of the else. This says that if it is indeed greater than 90, you don't need to look at the other conditions. It's just pointless. Which means that I no longer need this. So I'm now simplifying my program. So if the average is greater than or equal to 90, print excellent. Else, if I reach the else, I know that the average is not greater than or equal to 90, so it means it's less than 90. If it's greater than or equal to 80, print good. And then another else over here for the next or for the inner if. That means it's not greater than or equal to 90, and it's not greater than or equal to 80, which means it's less than 80. This is an example of a nested if, which is an if within an if. So let's write the program. Let's first test 90. And 89 and 91. I'm getting excellent. Let's test less than 90. So 89 and 90. I'm getting good for 89.5. Let's do 80, 79, and 81. I should be getting good because the average is 80. 79 and 80, that should give me an average of 79.5. So it should display more work needed. I hope this example makes sense. Again, the last two parts are probably the more challenging parts, in which we introduce the concept of, based on the reading, of course, compound conditions as well as nested ifs. This, again, still isn't the best way to solve this problem. Multi-way if statements would work much better in this scenario, but this is a topic for a different time. So for now, this should be the last thing we're going to include in this video. Thank you much.